Hey everybody. Today you can see the title on the screen. We're going to go through a review of domain and range. Now this is a topic that you should have covered last year. So what we're going to do is we're going to do a very quick review to make sure we're on the same page, and then we're going to kind of extend it a little bit for the last part of today. Okay, today should be a fairly smooth day, I'm hoping. Let's jump right in. So what you see at the top of the screen now, there's going to be our instruction for the entire day. All we're going to do is we're going to take certain relations and functions, and we're going to go through and we're going to determine the domain and range for each of them. So you see in problem A list of points. This is our review portion for today. I want to make sure that we're good on domain and range. So if you recall, and if you're coming into this day with this idea of domain and range, you are exactly where you need to be. If you have tied together your domain being your X values, as well your range is your Y values, then you are good. Yes, we are talking generically about a function, so there is no application to it. We're not saying that this relation represents height versus time no, it's just generic, X and Y. Then my inputs are my domain, which are my X's, and my outputs are my range, which are my Y's. Now, I want to tackle problem A two different ways. This is going to then kind of sum up our review for today. If you take a look at that first problem, you would need to do nothing other than look at those points and state your domain and range. So if we acknowledge that domain is my X values, then I could list out my X values. So I could say then that my domain, and that's all I'm going to do. I'm going to put my D for my domain. Now, there are very formal statements. Very formal. We're not going to ask that level of formality. So for us, what we need to do, list out our X values. Now, when we make a list of values, then we're saying that these numbers are a part of a set. And when we list a set of something, then we list them with our brace brackets. So there's my fancy looking bracket. I am going to open up a bracket for that set of values. Now I'm just going to get rid of that, write that a little smaller so you don't have to see it so accentuated. Now, the other part of us listing domain is there is a set order to it. So when I scan my way across all of those points, I am circling all my X values. For me to write out my domain, I would not list them as -2, 4, -1, because those aren't in the correct order. When we list our domain, we list them in increasing order. So I'm going to look across all my X values, and I'm going to find the smallest one. And then I'm going to increase from there. My next largest, my next largest. Now, we also don't repeat values. What I'm listing in blue are the X values that are present, that are represented in that relation. So you wouldn't list an X value twice just because there happens to be 2 points there. So I go through and I list my 4. That is my last X value. Now I need to close my set, and there is my domain. So there we go. Okay, I want you to pause it, take a shot, fill in your range. Okay? Pause it now and we'll come back. Okay, we're back. So if I'm going to find my range, then I could go through. I mentioned earlier about the formality of things. There's times where we could denote for range where you will end up seeing a Y is an element of, and then the list of Y values. I'm not going to make you write that. When we get into sets of things that aren't individual values, that is, they offer a range of values, then we'll talk a little bit more about that formality. So I'm hoping that what you end up having is your y values all circled in red, not that you had to circle them, but that you put them in increasing order. So my lowest was 2, then 3, then 6, then 7, then 9, and you closed it with a beautiful brace bracket. There we go. Okay, that hopefully was some review from grade 9. All I want to do now is I want to make mention of what that would look like graphically. So I'm going to take those values, and all I want to do is I just want to kind of shrink it down a little bit. So I'm just going to get rid of at least those red circles, and now come over and draw a quick sketch. So if I put down a quick set of axes, and all I did was I labeled all those points. I'm going to plot them. I'm not going to spend the time to label them. -2, 3 would be about there. Actually, let's just say about there. 4, 6. -1, 7. 0, 2. 4, and 9. Let's say that I had those 5 gold points. If you were asked that exact same question and this was on a graph, then you would read the coordinates of those points and list your x values. I'm hoping pretty straightforward. However, let's say that what we had was a picture. So maybe it did something like that. I don't know. Those points were connected. So it wasn't just that the 5 points that I plotted existed, but all the other points in between. If you had to state that, then the beginning point is very important for our domain. The end point is very important for our domain. You would then tell me for our domain that x, put that arrow in, is greater than or equal to -2 and less than or equal to 4. And of course, I do not care. If you wanted to use some interval notation, you could represent it that way as well. Either one of those. For our range, the same thing. I don't think we need to address an individual problem dealing with a graph. I think you should be okay to deal with that. Okay, I am hoping that that review covers everything that you're walking in here with regards to domain and range. What I want to do is I want to change gears now. Okay, let's take a look at problem B. So what I want to do now is I want to tackle domain and range, but I want to remove the graphical component. So we just addressed one that had a picture. I created the picture for you. But also, if I give you a set of ordered pairs, I'm really giving you the picture. So what I want to do now is I want to spend the rest of the day talking as if we do not know the graph. However, I am going to pop up some pictures from time to time. So what I want to do is I want to have a different focus then. I want us to address coming up with domain and range from the equation of the function or the relation. I want us to look at it from that perspective because we have to ask ourselves some questions that might be a little bit different. So let's take a look at B. You see that you have the equation to the relation y equals 2x plus 1. I'm hoping from our previous day that we recognize that that is a function because if I sub in an x value, I will only ever get one y value. One x has one and only one y. We're good. So I can start calling this a function. But what about domain and range? So when we are talking about domain, remember, we are talking about x values. So if I'm looking to address my domain, then really what I'm looking at is maybe the opposite. That is, sometimes to answer a question, it can be easier to see what's not there, what I can't use, in order to figure out what I can. So one of the things that I might be looking for to address my domain, is there any X value that I cannot sub in? So I'm looking for the not case. Okay, is there an X value that if I replace that X in my equation, I double it and I add 1, that I could ever go, yeah, I can't calculate that. It is impossible to calculate that. I'm hoping that we recognize, no, you could replace X with any number, and you can always double it and add 1. And because you can always get an answer, that means that X's then are part of our domain. If I can sub in any number and calculate, then that means for my domain that X can be anything. That's how I want to see your answer. In gold off on the side, this is technically correct. That X could be anything from negative infinity up to infinity because that represents all possible values. I just don't like it. It's a personal preference. I just don't like it. To me, it's a weird way to say go forever left and forever right, when you could just say what we said in blue, X can be anything. Okay, now let's take a look at range. So for us to determine range, then we're talking about the Y values. This one's a little bit different because we are talking about output. So now we have to try to imagine what sort of answers are we going to get when we can sub in our domain, so anything for X. Similar to domain, sometimes it's easy to answer the question not. And what I mean by that again is, are there going to be any Y values that we cannot get? So imagine subbing in anything you can for X. Can you see a certain type of number or a certain value that will never come up as an answer? I'm hoping that we can't, that we imagine, no, I could pretty much get any answer I want depending on my X. And therefore, we would end up stating that the range is also anything. So Y is an element of the real numbers. Same thing, I'm not going to repeat it for that gold interval notation. Okay, I mentioned that we don't want to do this as a graph. However, I think it's worth noting for us just to take a peek at the picture. If we take a peek at that, we recognize that what we have is a line, and it has a slope of 2 and a y-intercept of 1, so something similar to that. You take a peek at that, that is realistic. I pass through the y-axis somewhere, let's call it 1, and I'm a little bit steeper than my 45. So, if that's the case, then you should be able to take a peek at that green line and we can confirm our domain and range. You take a peek, I put arrows on the end of that line telling me that that line goes on forever and ever, which means we will eventually cover every X value. So check, that works. Domain X could be anything. But then we also take a look at our range, and we notice that since those arrows are on the end, that my line is going to extend up and down forever. And therefore, check, our range is that Y could be anything. Okay, I'm hoping that that helps us. Our goal for today is to be able to figure out domain and range from an equation. Fighting as hard as we can, even though I'm going to talk about it, fighting as hard as we can to not consider the picture. Okay, let's take a look at C. So let's take a look at the function given in C. Y equals x squared. Okay, we don't want to look at this as if we have any idea of what this graph looks like. So we just want to look at it as an equation. So as we're trying to come up with domain and range, try not to think of the graph. Okay, I want you to give this one a shot on your own, and then we'll come back and we'll see how well we did. Okay, pause the video now. Okay, we're back. So we take a look at C, y equals x squared. For me to come up with my domain, I'm now trying to consider what x values can I sub in and be able to calculate. It may be easier to say the not case, the anti case. Are there any x values that I could sub in where I cannot square it? I hope that we're good that in both of those cases, any x values work. Therefore, x can be anything is our solution. Okay, now we jump to range. For range, we're now considering the output. So what type of answers do we get when we square something? So you're either thinking of the affirmative, the positive, what type of answers do we get, or we're thinking about the anti-case, the not case. Are there any values that I would not get when I square? I hope we're good that in both of those cases, negatives become a problem. That is, every time I square a value, I always get positive or 0. But I can never get a negative value. So negatives will not ever come up as an output. Therefore, my y value is always positive or equal to 0. And there would be your range. Similar to what I said before, if you happen to state that in interval notation, then you may have said 0 is your lower limit, and we go forever up. And there we go. Okay, hopefully we matched up. Like I said earlier, I'm going to go ahead and put on a quick sketch. If we are familiar with, depending on the order in which we are doing some things, there is my function, y equals x squared. That parabola gets wider and wider as we extend it up. It will cover all x values. You can see that nowhere in that parabola does it exist below the x-axis, so my y values are always positive or 0. Okay, there we go. So hopefully we're getting the idea of trying to imagine what types of x values we can get, or we can sub in, and what types of outputs, y values, we will get. Okay, let's jump into the next one. Okay, you take a look at the function given in D, y equals root x. Same thing, I want you to give it a shot on your own. Okay, let's pause the video now. Okay, we're back. So we start to take a look at that, and we're imagining for our domain, what types of x values can I sub in? Or, the not case, are there any x values that I cannot sub in? And I hope we recognize that you can take the square root of positive numbers. You can take the square root of 0. However, taking the square root of a negative value is not going to work. We cannot calculate that. And so we look in the blue, and I'm hoping that we're good that your x must be greater than or equal to 0. Same thing as before. Perhaps you said 0 to infinity. Okay, there is my domain. Now I need to address my range. So I take a peek at my range. What types of y values will I get when I calculate root x? Well, when we calculate the square root of 0, we get 0. We know when we calculate the square root of any number, we cannot get a negative value. Look at the sign out in front of that square root. It's positive, so I'm never going to get negatives. When I take the square root of a positive value, I'm going to get positives. So what I don't end up getting then are any negative values. I can get 0 and I can get positives. When I take a look, I will start to get bigger and bigger positives as the number underneath my root gets bigger and bigger. Like the square root of 9 is 3, but then the square root of 16 is 4, the square root of 25 is 5. Notice, as the number underneath gets bigger, my output gets bigger. So my range is going to keep growing and growing and growing. Hopefully then we were comfortable with y has to be greater than or equal to 0, and same thing on the interval notation. Okay, hopefully we matched up. Now, you are unaware of this, but for a picture, this is what your square root function looks like. It starts at 0, 0, and it exists everywhere to the right because you can sub in positive values for x. As your x gets bigger, your y gets bigger. And so even though that curve is going to become flat and flat and flat and flat, it still does rise. So every y value would be taken into account. Okay, again, hopefully we matched up. I want to jump into a couple more. Here we go. Okay, this could be one that could throw you for a little bit of a loop. I want you to go ahead and give this one a shot. Try it on your own, and then we'll come back and we'll see how we match up. Okay, pause the video now. Okay, we're back. So we take a peek and we say, well, I can see where the x is. It's right there. It's on the bottom of my fraction. But now when we're trying to imagine what types of x values you could sub in and be able to calculate stuff, this is where it could become a little difficult. I think that this is a great example of finding the not case. Like, let's go on the hunt for what can't work, since it seems like there's so many x values that would work. So if I examine where that x is, take a look, it's on the bottom. I start to think it's on the bottom of what? Well, it's on the bottom of a fraction. So I start to imagine, well, is there anything that would cause me a problem about the bottom of a fraction? And maybe it kind of comes back to us, well, you know what, if my bottom was like 1, I can calculate that. If my bottom was 2, I could calculate that. Okay, is there any number that could pop up on the bottom that I couldn't calculate? And maybe it jumps into your head that that would be a problem. Remember, if I have a number on top, like 1, like anything, and I divide it by 0, I cannot calculate that. That value is undefined. So a denominator of 0 becomes a problem. I can have anything else in my denominator, just not what makes the denominator 0. So if I look back at my fraction now, and I just zero in on my denominator, then you could probably figure out through inspection what x value would make that denominator equal to 0. If we can't, then make the denominator equal 0 and solve your equation. Notice that when x equals 2, that's going to make your bottom equal to 0, which would make the fraction undefined, which means we wouldn't get an output. So that means that my x value cannot equal 2. Okay, here's where I want to make sure that we are all very clear in terms of expectation of the course. Technically, you should write that x can be anything but not 2. You should technically write that. However, this is where we bring in some other notation. If I now gave a correct statement, then what I would actually do is write this, and this is where it's going to look a little weird. What I should say is x is an element of the set of x such that x is an element of the real numbers, but x does not equal 2. Oh my goodness, look at all that notation. That is not needed. So, we're going to have a little understood rule in our course. If you tell me that x cannot equal something, then we're going to go on a rule that implies it can be anything else, which means you do not have to state that x can be anything but. We're also going to forego any of this formality about x such that. And if you shrink down that whole statement, I would be fine with you just giving me that your domain is that x cannot equal 2. If you tell me what it can't equal, we will all assume it is everything else. And I think that's a fair assumption to make for us. Okay, there we go. There is your domain. Okay, I'm going to just get rid of all that stuff on the right. And so if you had a bit of a snag coming up with domain, that should give us a chance. Okay, now that we've done that, maybe I've caught up with you a little bit. So here's another opportunity to pause the video and try to come up with range yourself. Okay, pause it now. Otherwise, here we go. Now I'm trying to look at it and say, okay, well, my range is my output. There's my y's. Okay, what sort of answers am I going to get for y? And as you're trying to think of all the possible numbers that would pop up, this becomes another opportunity where maybe the not case is easier. You take a look at what you have. Go back to your function. It is a fraction. I start to think about all the values I could get with that fraction. Well, can I get positives? Yes, like if I made my bottom 3, then 1 over 3 minus 2 is 1 over 1, which is 1. I get a positive. As my x becomes bigger and bigger and bigger, then my denominator is going to become bigger and bigger and bigger. It's not going to change the value that I get positives. All it's going to do is it's going to make my overall fraction a little bit less. Right? Instead of 1 over 1, it's 1 over 2, 1 over 3. So let me just change that. 1/2, 1/3, 1/4, 1/5. It's becoming smaller and smaller. Okay, can I get big values? Well, this might be something you didn't consider. When I have 1 over, what if I said like 2.5 for my x? Now that becomes 1 over 0.5. That might be easier to consider if we think about it as a fraction. Now that I'm dividing by a half, that really means flip and multiply. There's 2. There's how I can get bigger numbers. As my x value gets closer and closer to 2, my denominator is going to become smaller and smaller. Since my denominator is small, 1 divided by a really small number actually becomes bigger. Okay, we get to the other side of that 2, and all of a sudden, my denominator becomes negative, and that's where all my negatives come into play. So I've already figured out that I can get positives, big and small, and then obviously negatives for all the same reasoning. Okay, is there any value that will not pop up? Well, what about 0? Okay, this comes back to we have a fraction. So if I gave you a fraction, I don't know, a over b, and I said, how do you make that fraction equal to 0? I would hope that relatively quickly, through our discussions elsewhere in the course, that we recognize that the only way to make a fraction equal to 0 is to make the top equal to 0. I know my bottom can never equal 0. That would give me undefined. So when I take a number on top and I divide it into a certain number of groups, the only way that I get 0 is to start with 0. This is that example that we use when we talk about the number of pens on our desk. If I start with 0 pens, then I can break it up into any number of groups, and I'm still going to have 0 pens in each group. If I start with nothing, I will finish with nothing. Well, take a look back at your original function, and you will notice that up on the numerator, you have a 1. That top on that fraction is always 1. There's no variable up there, so it cannot change values. Because of that, because my top is always 1, it can never equal 0, and therefore my whole fraction can never equal 0. Okay, for all the same reasoning we spoke about with our domain, all you would have to write is that y does not equal 0. I wouldn't make you add in all the other detail. Okay, as I mentioned, that one's a little tougher. Okay, let's jump into our last one for today. I want you to take a look at f, and there is f. X squared plus y squared equals 16. Remember, you're not even thinking about what that looks like as a graph. I want you to go through and determine domain and range. Okay? Pause the video now. Okay, we're back. So I'm going to break my rule again. We should all be good that this is our good old circle, center 0, 0, and radius 4. So if you were to think about it as a picture, we should be good that on our x-axis, our circle is going to exist everywhere from -4 up to 4. Okay, here's where I want to walk it back again. We don't know about the picture, even though I'm just going to leave it up on the top right of your screen. We don't know about the picture. How could we come up with domain without the picture? The advice I gave to you before, manipulate your equation. I think that's going to be easier. If you took a look at it and you said that you're going to get your y all by itself. And so you're going to take the square root. When you take the square root, you get plus or minus. We come in on this, and that should look very familiar. Now when you're trying to consider domain and range, when I look at domain, I'm looking at my x values. I can now see that that x is underneath my root. So I start to think about all the things that are possible or are not possible, and I know that I can't have a negative underneath my root. So I start to imagine what is going to make 16 minus x squared a negative number. And the way that I could write that, what is going to make that less than 0? That's negative. Well, I start to look at my x value and I say, well, right now if I was to sub in x equals 4, then 4 squared is 16. That gives me 16 minus 16, which equals 0. That's okay. But as soon as I get a value a little bit bigger than 4, this bigger than 4 squared term is going to be larger than the 16, and so when I subtract it, I'll get a negative number. So, for instance, if my x value equaled 5, well, now I get 16 minus 25. That is I don't even care that it's -9. It's negative. If I was to sub in 4 let's just say 1, as soon as I get to the other side of 4, when I square it, I get something bigger than 16. That's my problem. So hopefully then, from examining that equation, you can see that my domain tells me that x has to be less than or equal to 4. Okay, well, what about a minimum value? Like that is, you'll notice like x could be 0, 16 minus 0 squared, that's 16. That's nice and easy to calculate. Right now, my blue statement says that as long as x is less than 4, we have no problem. So like 3, 2, 1, 0, -1, -2, -3, and maybe you can see where we're going. For everything we just discussed, if I was to say, let x represent -5, well, now I get a root 16 minus, well, -5 squared is 25, and I'm running into the same problem we did before. So you'll notice then there is a minimum value that x can be. So what is the smallest value? It's what gets me that 16 underneath, -4. And I wrote that way too big. X must be greater than or equal to -4 to make sure that we have positives underneath our root. Okay, this would be one of those problems where I think my default would just be to write interval notation because I have a closed statement on both ends. Okay. More difficult looking at that from the equation than from the picture, definitely. Okay, you clearly have your picture up in the top right corner. Now we have an opportunity to look at range. This one's a little more difficult. If we were to address range, well, if I look up on my diagram, just so we can kind of have a little bit of confirmation, we should be good with my circle going all the way up to 4 to -4. So you can see what your range is right now. What if we didn't know the picture? Okay, I'm going back to that gold equation. When we have plus or minus root 16 minus x squared, the plus or the minus tells me I can get positive or negative numbers. So I can already see that in my range. The other part, I now have the root. Well, that just means I'm going to calculate some stuff. But when I calculate square roots, I can get a lot of different answers, big and small. What's underneath the root is the key. There is my 16 minus x squared. That's my focus. So I start to think about what can give me the biggest possible value out of that. The biggest. Well, the way that I can make my maximum value, 16 minus x squared, the way I can give that as a max would be to take 16 and subtract off nothing. Okay, and I want to jump into this a little deeper. Because I'm going to square my x, that means whatever x squared is will always be positive. So when I subtract it, I am always going to take my 16 and subtract a number that's always positive. I'm never subtracting a negative. And anytime I subtract a positive, I am making something smaller. So how do I make that as big as possible? How do I make that my maximum? I need to make what I subtract as little as possible. 0. Remember, I can't make it a negative because of the squared. So the smallest number I can get is 0. When I get that 0, and I calculate now, well, 16 minus 0 is 16. So if I come back and I now calculate my stuff, I get plus or minus the root of 16. And when I calculate that, then I get plus or minus 4, and you can start to see that answer up on the board, up on your picture. Okay, that isn't enough to make my determination, even though you may see it on the picture. What I now need to do is figure out, well, what about the minimum? And I can go through the same process. I need to make sure that 16 minus x squared is always positive or 0 so I can calculate. That's part of my domain. Well, what is the smallest possible value I could get? Well, the smallest possible value I could get would be to subtract off everything that I had. If I subtract away everything, then that leaves me with nothing. My smallest possible value. And if I go back and I now calculate, then I'm going to get plus or minus the root of 0, which is 0. And you'll start to see then that I'm going to get everything in between -4 to 4. If my max got me to my plus or minus 4 and my min gets me to my 0, then as I float in between my max and my min, I have to come in between 4 and -4. Okay, that means that if I come back over and I address my range, my y values have to be greater than -4, but always less than 4. And same thing if you're looking at interval notation. Okay, I think F is probably the most difficult one for you to work through when you address just the equation. And yes, it absolutely helps that we've already covered what a circle looks like, and so we can recognize that from its equation. Okay, your job today. Fight as hard as you can to not consider the picture. Look, if this was an evaluation, you use every means that you have at your disposal. I would absolutely use the picture if I knew it. But for today, what I want you to do, try to get some practice only focusing in on the equation. Okay, jump in and get some practice. I hope it goes well. Best of luck.